Okay, YouTube, this is my second video on my module on graphing linear inequalities, in which we're going to look at a situation where when we test a point, and in our last video we saw that the point we tested was this point 0, 0, just because it was really convenient. But when we test a point in this video, essentially what we have to do is choose a test point that lies in one of the half planes that is not on the line that is dividing the half plane. So we say that the test point 0, 0 truly is convenient because it's easy to calculate when 0 is substituted for each variable. However, though, if 0, 0 lies on the dividing line and not in the half plane, then we have to choose a different test point. And so what we're going to do is look at this example here where we have y greater than, just greater than, negative 2/3 x. And so one thing that is to be mentioned about this here is that we have something that's in this y is, I guess, greater than, but mx plus b form. So we have slope-intercept form, and the two things that we want to do here after rewriting this as an equation first. So if we're going to graph the solutions here, rewrite it as an equation. But the two things we want to identify are the slope. Looks like we have a negative 2/3, and then our b value, because we have no b value that's showing up here, it must be a y-intercept of 0. So graphing this, suppose we would start at 0, 0, draw a dot, excuse me, and I'm going to put an open dot here. And we'll talk about y here in a second, but an open dot, and because our slope is negative 2/3, and that's our rise over run, then from this point what I'm going to do is I'm going to go down 2 and right 3, and I'm going to put another open dot here. And so through these 2 points that I put open dots on, what I'm going to do is I'm going to connect them, and I'm going to use a dotted line. And this dotted line is really being used to indicate all of the points that are on the line y equals negative 2/3 x. So we're going to label this, and when we do, we're going to label it with an actual equal sign. But the reason why I put dotted points here is because, or open points, is because these points are not actually on the line, because if they were, then this would have been greater than or equal to. And so because we mean all points just on one side or the other but not on the line, we say just greater than. What we want to do now is test a point. So you'll notice at 0, 0 we cannot test 0, 0. Cannot test 0, 0 because it's on the graph of the line. So because, we'll put it this way, because it's on the graph of the equation that was associated with this inequality. And so if we're going to choose any other point in a half plane here, we could choose some pretty easy points like negative 1, 0, 0, negative 1, but even easier would be 0, 1, and 1, 0. So I'm inclined to test here. How about we test 1, 0? And so we're just asking right now, when we plug in this point 1, 0, do we get a true or false statement? So to test this point in our original inequality, we say y greater than, just greater than negative 2/3 x. Then we'll make our substitution here. We say greater than negative 2/3. Let's try this again. Negative 2/3 x, where our x value, at least the one I've chosen, is 1, and our y value is 0. So we could say that this is clearly on one side or the other. We have 0 is greater than negative 2/3, which last time I checked, 0 is indeed greater than negative 2/3. So since this is a true statement here, then that means that 1, 0 is actually a true point. And so because that's true, then we would shade that point in. But if we're going to shade that point in, then we would shade all points in this half plane here on this side line. So what I want you to do is go ahead and graph this inequality that's in slope-intercept form, making sure to either put a dotted or solid line as appropriate, and then find which half plane you would shade by testing a point that's not 0, 0. Cheers.